Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? We're going to continue using tables to identify relationships. However, we're going to be identifying relationships between two different tables today. These problems are not in your notes, so I'd like you to complete these on scratch paper and then turn them into the Bell 2 bin or whatever bell you're in. I just was looking at the Bell 2 bin. Any bell that you are in for math, turn them into that bin, and we'll give you some credit for these. So here's our first situation. All right, a reminder that when we're looking for a rule to write the expression, we're going to consider the numbers being compared, and we need to look for this consistent relationship, right? It needs to happen over and over. All right. So during summer vacation, Julie read 45 pages each day. She must really like to read. Her brother Brett read 15 pages each day. So complete both tables to show how many pages each read after 5 days. And then we're going to look for the relationship between the patterns in each table. So let's start with Brett. A little bit smaller numbers, right? If he reads 15 pages every day, then that means each number going down is going to be 15 more than the number before. All right, so if it's 15 here, 15 plus 15 is 30. And then another 15 is 45. And then another, 15 is 60. And then another 16 is 75. So on the 5th day, Brett read 75 pages. Julie reads 45 pages every day. That means every day, right, she's 45 pages farther into her book. So 45 plus 45 is 90. If you need to be writing these down, please do. Show scratch work, show it in the margins, write it down somewhere, right? All right, 45 more pages is 135. Right, what it could look like is something as simple as this, right? 45 plus 45 is 90, right? Plus 45 is 135, right? Plus 45 is, right, 180. Plus 45 is 5, 2, carry my 1 is 225. Right, so the relationship on the 5th day, right, so far is Julie has read 225 pages, and Brett has read 75 pages. Okay. So, what is the relationship that we notice? I'm going to erase some things here so that we can start to have a little bit of space to work. And so this is a little bit different than the tables we were looking at in 15.1 where we were just looking vertically, right? Because at this point, I am now comparing the numbers that I'm going to circle. So those numbers are getting compared. These numbers are getting compared. These numbers are getting compared. Right? These numbers are getting compared. These numbers are getting compared. And what I'm looking for here is a relationship, right? And that relationship would be a rule. So if I started with Julie or Brett, how could I get from one to another? So, a couple of things that I notice here. One, if I'm going from Julie to Brett, my numbers are getting smaller. That's going to be a division or a subtraction rule. If I'm going from Brett to Julie, right, if I started with Brett's numbers and I'm going to Julie's numbers, 15 to 45, those numbers are getting bigger. That's going to be addition or multiplication. So what I want you to do is I want you to pause the screen and I want you to see if you can find a relationship. So I've started here with going from Brett to Julie, and so with my numbers getting bigger, the relationship that I found was times 3, right? But 15 times 3 is 45, and 30 times 3 is 90, and 45 times 3 is 135. So the relationship could be written as this, right? Julie always reads 3 times more pages. That's an R. I needed a P. Pages than Brett. Right? If we go the other way, right? If that relationship is times 3, then this relationship must be divided by 3, right? And 45 divided by 3 is 15. 90 divided by 3 is 30. Right? 180, divided by 3 is 60. And so what I can say here is that Brett always reads 1/3 of the pages Julie reads. Right? So that no matter how many pages it was, right? If I know that Brett reads 300 pages, okay? 300 times 3, right? That means Julie read 900 pages, right? If I started over here, 900 pages, 900 divided by 3, Brett has 300 pages. So those are our relationships. Let's look at another situation. Jack is training for a race. Each week he runs 30 miles and bikes 120 miles. He created a table to track his progress. How many total, that's an important word, miles will he run and bike after 5 weeks? So can you identify any relationship between the miles run and the miles biked? So first things first, on this should say weeks, right? On week 5, how many miles did he run and bike? So that's going to be our first step. So find that now. So he ran 150 miles in week 5 and he biked 600 miles in week 5. That is a lot of running. Right, and that's a lot of biking. So, right, total here, total after 5 weeks, right, is that he's gone 750 miles total. And I got that, right? By after 5 weeks, I just added the two numbers together. The second thing you need to figure out is that what's the relationship between miles run and miles biked? So pause the screen, find a relationship, and write a rule for us. So when I first looked at this, I saw two different things. I saw it could either be plus 90 or times 4, because 30 plus 90 is 120. 30 times 4 is 120. But when I look at down here at the second week, right, 60 plus 90 is only 150. So plus 90 doesn't work. There's an easy way that you can check if times 4 works, right? And if you'll recall, that's where we just look at the numbers that don't have zeros, right? So 6 times 4 is 24, 10, 10. 9 times 4 is 36, 10, 10. It appears, right, that that's our consistent relationship. And so Jack bikes 4 times as many miles as he runs. Okay. So your next steps would be to turn this work in so that you could get some credit, and then complete the practice buddy for 15-2 and see me if you have any questions. Have a great day.